What's going on, everybody? Welcome back to another Blueprint to C++ tutorial series where we continue building our plugin for the inventory. In today's episode, we do some world item rebuilding. We rebuild it in C++ and then do some debugging, get it over into blueprints. We reparent some things, and we got a lot going on. This is going to be part one of part two of this little mini example that we have here. But by the end of it, what you'll have is your world item in the world, and we're going to have a little widget popping up over all of our items that are interchangeable with what we're looking at. So interact to pick up red berries, interact to pick up bread. So that's what we have. Looks pretty simple, a lot of work. So let's get right into it. All right, so before we get started in today's topic, I wanted to come back in here. I'm in the inventory component header file. There was a lot of discussion this past week after the last video dropped about this particular pointer here, where I have an inline static. I did this originally, for one, I just wanted to show something a little bit different, but my logic in implementing this might be a little bit flawed. Some of the questions came into is how much are we saving here? What's the point of using both of these? I'm setting this as a null pointer here, and then in begin play, I'm instantiating it there in begin play. So by doing that, am I actually having any saving benefit by using inline static, because we're instantiating it on every begin play? So there was a lot of good questions. There are a good lot of debate in there. So we came up with a couple different ways that we can handle this. One would be to create our own custom macro, and that would be a legitimate way to do it. There's a lot of pros and cons about using macros. So what I'm going to end up doing actually is something kind of similar to this, but I'm going to end up creating a function for this. So let's scroll down here to the function section of our inventory component header within the protected section directly under the begin play. I'm going to create a new function. I'm going to make this an inline function. And again, inline, what this means is this is going to take the code and not make a function call whenever we're getting the character. It's not going to make a function call to get the character. It's going to insert this code if it can. This inline declaration suggests to the compiler that we can, and if your code is legit, it will put it in there. If there's problems with it, it won't. You can do force inline, the force inline macro, which will force it to be inline, but I'm gonna just do an inline here. If it doesn't get inserted, that's fine. If it makes a function call to this, it's not gonna be that big of a deal, but I'm gonna do an inline. I'm gonna make a pointer to a character, and I'm going to name the function getChar, and it's going to be a const function. Now, I did a little bit of research. I was able to put a t-object pointer here instead of a raw pointer, but I'm not sure. I can't find any documentation on if you should be using t-object pointers in function calls like this. So we can still use raw pointers. That's fine. So I'm going to keep this as a raw pointer. So let's go ahead and create the definition for this. Okay, and within this definition, it's going to be super easy. We're just going to go return uGameplay statics get player character. Now, before I used get world, which is a legit way to do it, but this makes an extra function call. So if we're trying to save a little bit of performance by using this particular function that we're creating here, then we don't want to counteract any of that by making an extra call that doesn't need to. So instead, what I'm going to do is I'm just going to type this, because the inventory component has a reference. It's a world context object. So we can just use this. It is fine for that. And we're going to go player index of 0. And that's it. This is what our function is going to be. So instead of having this character here in begin play, we set character equals gameplay static get world. We don't need that anymore. Instead, what I'm going to do is I'm going to find all the references where there's character here and make a call to that function. So I'm going to go get char, and the only reason why I named it get char instead of get character was just for simplicity reason, because it's a little bit easier to type, so you can name it whatever you want. And there we go. Everything should be corrected now. So if by deleting the character reference there and coming up here and deleting the header definition, if we come back here to the CPP, if we don't have any red errors, then we got everything. So again, this is just going to take that line of code and it's going to insert in here at compile time. You won't ever see it. It's just easier to type that. And technically we're not creating any extra overhead by having an additional pointer. So we're just dereferencing here at the header. We're just dereferencing the pointer that already exists for this function call here. We'll have a little bit of cost savings. Wherever we can save is a good idea. So I just didn't want to create a whole bunch of pointer variables to the same thing, given that we could have hundreds or even possibly thousands of these inventory components existing in the world at any given time. There's no need to have an additional pointer to the character when in fact getting to the character pointer is very easy to do in the first place. All right, so let's go ahead and move over now to our world item. All right, so over here in the world item header, first thing we're going to do, the only thing really I think we're going to do here in the header file today is I'm going to come up here to the uClass definition, and I'm going to make this abstract. So that way this object should not exist in the world, but I'm also going to make it blueprintable, meaning that we can derive blueprint classes from this. Now, without this, we would be able to reparent to this, but we don't really want to do that. You want to make sure that this is blueprintable so we can make children derived from this class. All right, so head over into the world item CPP, and in the constructor here, right below the can ever tick false, let's get our display mesh, and we're going to create a default sub object. It's going to be uStatic mesh component, and I'm going to give it a name of display mesh. And then we're going to set the root component to be the display mesh. I want this to be the root component of the world item. I'm going to go display mesh, set collision object type. So the type of collision object we want this to be, we want it to be ECC underscore world dynamic, ECC world dynamic, display mesh, set collision response to all channels. We're going to go ECR underscore block. And if you don't understand what these ECC and ECR is, E stands for enumeration, C stands for collision channel, and E for enumeration, C collision, R for response, collision response. We're gonna come down here, display mesh one more time, set collision response to channel. And we only want to do the singular response to channel. We're gonna set ECC visibility, and we're gonna set its response to ignore. I'm gonna come down here and I'm gonna take our billboard, and I'm gonna create a default sub object of uBillboard component, and I'm gonna simply name this billboard. Now we got the red squiggly line here, so we need to include this file. There we go. I'm going to go billboard again, and we are going to set up attachment to root component. Lastly, the interact widget, create default sub object uWidget component, and I'm going to simply name this interact widget. And then we're going to go interact widget again, and we are going to do a setup attachment, and we are going to attach this to the display mesh, which technically is the root component. We could type root component here, but I'm going to ensure that it sticks to the display mesh because that's where I want it. So if you do end up removing the display mesh from your root component, then it will still be attached to the display mesh. So that's why I'm being explicit there with that. All right, so now we have our constructor all set up. Let's head down to the begin play, and I'm going to take my begin play here, and I'm going to actually cut it and move it up here towards the top. You can have it wherever you want. It just makes a little bit more sense for me to have this up near the top so it's easier to find. I try to be consistent with that. So let's head over into the editor real quick, and let's take a look at exactly what we have going on in the begin play. All right, so here within the editor, we have the event begin play here. We're in the world item blueprint, and what we're doing is we're setting the static mesh, and by setting the static mesh, we're getting the object class, getting its class defaults and pulling the static mesh from there. We're also then setting the despawn time by getting it from the class defaults again. Then we're going to set the set simulate physics to the display mesh, and then we're going to run a branch to see should it die, and if it is, then we're going to set the despawn timer, which means then we're going to have to come down here and set the despawn time. Now, in our C++, we've actually changed this out, right? We don't have the class reference here. Instead, we have a soft class pointer. And so, which means we're going to have to async to get this class defaults of this. So I'm going to show you in C++ the two common varieties of async that I use. So let's head back over to C++ and get this going. Okay, so we're back here in begin play. So I'm going to come down here. So first thing we need to do is we need to go if item type dot is pending. Now we want to use is pending here. We don't want to check is valid when you're working with soft pointers. You want to use is pending. So what this does is it tests if this does not point to a live view object, but it might in the future. It returns true if this does not point to a real object, but could possibly. And you can see there it comes from the soft object pointer header file. So this is what we want to use when checking soft pointers. If you check is valid, you're going to get false positives. So you don't want to do that. All right. We want to check is pending. So first, let's go ahead and create a local variable. It's going to be of type F streamable manager, and it's going to be a referenced variable named streamable, and it's going to equal u asset manager get streamable manager. Now, as you can see there, this accesses the streamable manager used by this asset manager, static for easy access. So that's all we need for that. So now we have a variable called streamable that contains the streamable manager. Now we're going to take streamable and we're going to request async load. In here, we're going to take the item type and we're going to call to soft object path, comma, F streamable delegate. And on F streamable delegate, there's several different type of delegates that you can call in this request async function. There's two that I use regularly, the create lambda and the create uobject. I'm going to show both of these to you in this one particular file because we have to async check a couple times. This first one, we're going to do create uobject, and the next one we'll do lambda. Create uobject will probably be applicable for both of them, but I just want to show you both ways to do it because while in this particular case, we could probably just get away with using the uobject, not always can you use the uobject and you'll have to create the lambda. So I'm just going to show both cases to you here. We're going to start with the create uobject. And then inside uobject, it needs an end user object. So the end user object is going to be this. And then here we need to call a function that is going to be, this is going to be a function that is called when the async loads. So when it completes, when the async completes, we need to call a function. Now this variable here, if we were calling a function, say on our player controller, then we would put a reference to our player controller here and then call the function on our player controller. All right. But since the function lies within this particular class, we put this here, and the class I want to call is a world item set default. And that's it. That's all we need to do for that particular case right there. So again, we got the streamable uasset manager right here, the variable streamable. We request an async load, and on async load, we take the item type and we get the toSoft object path to this, which this is an internal function that we have on soft object pointers. We get this function call right here on all of them. And then we send it to the delegate of create, where we create a uobject, which lies on this a world set default is a function we want to call. Okay. So this is pretty simple, but again, this isn't going to be the best use case for every scenario. And I'll show you the other one here in just a little bit. So now with this, we want to go else, because this may not be pending. This may come up false, right? So if it's not pending, this means if this shows up false, this means we don't have to stream it. We already have it in memory and we can use it. So with that, if we do have it in memory, I just want to ensure that we do have a valid item type, right? It's always good to verify your parameters. So if item type set default, right? So I'm getting all these red squiggly lines because even though we didn't get it here, and I'm not quite sure why it doesn't show it here, probably because we're calling functions within that. But since we're not calling function on here, this essentially says that we have to include the ubase item in the file. So I'm going to include ubase item, and let me scroll up here and just show you what is included, because some of these things pop up without me including them because that's the way Ryder does it for me. So these are the includes that are within this file. So if you have any errors, make sure you have these includes, and all those errors should go away if it's typed correctly. Okay, so now with that gone, so if we do have access to a valid item type and it is in the world, then we call set default. So let's go set default function really quick. Okay, set defaults is going to be relatively easy. Let's go const ubase item. I'm going to make it a pointer, and I'm going to call this converted item, and this is going to equal the item type, right? Because Item type is a global function, or I say global to this source file, to this particular class. When we async it up above, then we can have it down here and it is already filled in and populated with the valid class. Okay, so it's no longer really a soft pointer at this, but we still need to be able to convert this into a UBase item, because even though this is a UBase item type, it's a soft pointer reference. So we need to create it into the actual base item in order to get our default objects. Okay, so with that, now we're taking a UBase item. I'm calling it converted item. Take the item type and we will go get default object, and it is a UBase item. We're casting it to a UBase item. So now that we have the default objects, we can go display mesh, set static mesh. We're going to go converted item, static mesh. Then we'll go display mesh and we will set simulate physics and set them to true. And then despawn time equals converted item despawn time. And then lastly, let's check if converted item B should die. Then we will go set despawn timer with despawn time. There we go. So that wraps up our set default. So now when the object loads in the world, it should be loaded with the proper static mesh and all that. So that takes care of the begin play. Let's verify that and take a look at our editor. All right, back here in the editor. So we are getting the class defaults, setting the static mesh, setting the despawn time, setting simulate physics, and then we're checking if we have a should die here, then we set the despawn timer. So let's go ahead real quick just to round this out, and let's create the set despawn timer function within the C++. So I'm just going to go ahead and disconnect this now, and then I will come back and delete this a little bit later. So let's head back to our source files. All right, and despawn, that one's going to be easy. All this is going to be is we're going to go set lifespan, and we're going to set this to time. Lifespan is an internal function, and we're just going to set it to the value of time that we're passing in. Pretty simple stuff. So now let's go ahead and work on our set look at implementation. All right, so if we take a look at the blueprint functionality of the set look at, you're going to see it's actually pretty simple to do here, right? All we're doing here is we're getting the render custom depth, and we're setting it to either true or false, depending on if we're looking at it or not. Then we're getting the item, the class defaults of the item class, and then we're setting them out. But we're going to do something a little bit different. For one, we are using the soft pointer instead of the class reference. So with that, we're going to have to create another async operation here, or at least check to see. We have to implement it just in case if it's dead. It shouldn't be dead in this application, but it just might be. So we have to account for that. So this is going to be a little bit more work than it shows right here. But as I mentioned before, we put the interact widget on our world item now, and I'm going to implement that to be seen. So sending these out isn't that big of a deal, but we're going to have to account for doing all the stuff for the interact text. So while this is simple here, we are changing this up. So let's head back into C++. All right, so here in the set look at implementation, I'm going to delete this line here. Remember, this line was just put here so we can compile it and test it last time. We had to have something there as a return type. So what we need to do here, let's start out. We're going to go display mesh, set render custom depth, and we're going to set it to B is looking at, just like we did in the blueprints. So there we go. So now we're going to render the outline if it is being looked at. Now let's go if B is looking at. We need to check if item type dot is pending, and if it is pending, then we need to build it using the async operation, or we need to load it using the async operation. So again, as I mentioned before, we're going to do this one a little bit differently. It's going to look the same. To start out, we're going to go f streamable manager, and I'm going to call this streamable again. It's going to equal uAsset manager, and we're going to get streamable manager. Then we're going to come down here and streamable dot request async load item type dot to soft object path comma f streamable delegate. Now this delegate, we are going to create a lambda. Okay, so let me do what I can to try to explain lambda. This is a very high level overview of what a lambda is, and I'm only going to do it in the context of what we're doing here. I'm not totally familiar with lambdas, but I will do my best to explain it. So lambda is an anonymous function that supports functional programming paradigms. So lambda provides a concise way to define small inline functions without the need for a separate function declaration. They're often used for different things, such as high order functions, defining custom predicates for sorting and searching different algorithms. And it helps with providing concise syntax for callback functions for asynchronous operations, such as what we're doing here, right? So there's a few things with defining a lambda. So what we need to do first off is we need to create what's called the capture clause. And what the capture clause allows us to do, and it needs to be in square brackets, is this specifies which variables from the surrounding scope, so which variables outside of this lambda function do we want to use within this function call, within the function body of the lambda. If you don't provide a capture clause, then you're not going to be able to use those variables and other parameters that you have outside. So we need to go this, right? So we want to have reference to this, the object itself within there. And then we're also, because we're going to be dealing with setting the interact name and the text for that, we need to have access to those here as well. So in order to gain access to those, you can't just simply type in the name of the variable. Here we got interact text and name. Those are our variables that we want to have access to in here. You can't type those in here. You're going to end up getting errors when we get through this. You need to actually give it either an equal sign. By giving it an equal sign, it captures all the variables by value, or we need to capture it by reference. So I want to capture these by reference. So if we did equal, it would just give us the value of those, but I don't want to do that. I want to be able to reference them. So I'm going to add the ampersand there, and then same thing here. Need to add the ampersand there, and there we go. So now we can have access to these variables within the lambda. So with that, at the end of the square bracket here is where we put our function body. So I'm just going to give us a little bit of space here. I'm going to create the function body just like we do. We got the curly brackets now, and that's going to define our function body. And to end it here, we need to end with a semicolon. So I'm just going to terminate it there. So technically now this lambda is complete and all the errors are missing, but we need to write our function body. So with that, I'm going to go if const ubase item. I'm going to call this converted item, and it's going to equal item type get default object of ubase item type. So again, this is an if, so we're setting the converted item just like we did back in the set defaults. Then within the body of this if, I'm going to go interact text equals converted item interact text. The name is going to equal converted item display name. All right, so now we just set those two variables. Let's go if interact widget. So again, if you don't want to implement the interact widget, then you can ignore this. There's going to be some more coding you have to do to enable the interact text in the name to show up on your primary HUD if that's the way you're going to do it. But again, I'm just going to stick with doing the interact widget. So that's what I'm primarily coding for in this example. So if interact widget and is valid, interact widget get widget. So essentially what we're doing there is we're making sure that we have this variable, that we have set this variable within blueprints, because remember, you have to set this in blueprints of what your widget is going to be. So we're making sure that we set it here, and then we're going to make sure that it is valid if we get the widget of this class, because if we get the widget of this class, then we just need to make sure if the widget itself is valid. And if it is, then we go if set widget indicator interact text and name. So we're calling this function here. So again, remember, we have to set widget indicator in blueprints. So we're checking here, this function itself, it returns true or false. So if you don't implement this in blueprints, it's going to return false. But if we set this and it comes back, it's going to set this information here for the widget interact widget, it'll set these there and return true. So if that's the case, then we can continue our code here that we need to do for setting the height and all that for our interact widget. If not, then it's going to ignore all this code. So make sure you implement this in here. If you're not getting the interact widget, it's probably because you didn't set the widget here or didn't set the variable inside the blueprint. All right, so if it did get through all that, I want to set the limits of where this widget is displayed. So what I want to do is I'm going to go display mesh. I'm going to go get local bounds. Okay, so now if we look at local bounds and hover over it, you're going to see local bounds needs an F vector minimum and an F vector maximum. Now, if you see F vectors on both of those, they have the reference sign on them. So if whatever we pass in here, it's going to go in just like it did with our line trace. It's going to go into this function and it's going to return a value and populate. It's going to give a value to our variables that we pass in. So let's create a couple variables for this. The first one is going to be well, they're both going to be an F vector. I'm going to call the first one min. I'm going to create another F vector. I'm going to call this max. And then if I come down here now, I can go min and max, and there we go. So now I'm going to create another variable, and this is going to keep the height of the widget within a certain limit, you know, because it could vary depending on how big your object is in the world. So something small, you don't want it to be below the surface or really high up, right? You want it to be near your object. So we're going to get the bounds. We got the display mesh, the local bounds. We got the minimum, maximum of that. But as far as its height goes, we're going to want to limit it. For me, I'm going to limit mine to be under 100 units, 100 centimeters high. So no matter how tall your object is, it's going to be no higher than 100 centimeters. So that way you can always easily view it when you look at the object. And likewise, it's not going to be any less than 20 centimeters off of the object as well. So it's going to be right within that range. Okay. So let's go float. I'm going to call this Z height, and it's going to equal F math clamp. I'm going to call max, which is our F vector variable above. I'm going to call the Z on max, and we're going to multiply it by the interact widget get component scale, right? So you may have a different scale on your widget, so we need to account for that. So if we have a different scale on our widget, we're going to make sure that we provide the correct math here for that. So get component scale dot Z, right? We only care about the Z height at this point. And then we're going to take it and divide it by 2. All right. So now we need to clamp it to which value. So the minimum value for that algorithm is going to be 20F, and then the maximum is going to be 100F. All right, so that clamps our Z height. So now we need to check if interact widget get component scale dot Z is greater than 1. So if we do have a scale on our widget that is greater than 1, then we come down here, we go Z height equals Z height divided by interact widget get component scale dot Z. Okay, so we're just adjusting the Z height if we do have a scale that is greater than 1, and we will go interact widget set relative location. It's going to be an F vector 0.F 0.F, and because we're only caring about the Z height, it's going to be Z height. Then lastly, we will go interact widget. Let me fix this. Interact widget set relative location right there. Sorry about that. Interact widget set visibility to true. All right, and that's it for the functionality. So if we come down here now to the end of this, hit enter, and we're going to type return. So essentially what we're doing is we're loading the variable item type asynchronously. So what this is doing here, everything within this lambda is not going to be called until the async is completed. So anything outside of this function or still remaining within this function can operate. So if you have other things to do within this function that can work simultaneously while this is loading, then you can continue to put it within this functionality. Otherwise, once this is loaded, it's going to skip back here and it's going to run the function within this expression right here, okay, within the function body of this lambda. All right, so with that, so now we're done with that first lambda. So this is what I was saying with having to type this twice, because normally you wouldn't really have to, but we're checking, is it pending, right? We got this if check here. So if we've already got it loaded, we don't need to run this bit of code here, but no matter what, this code that we just typed down here, this does have to be run again, regardless if it needs to be loaded or if it is already loaded. This code still has to be done. So like I said, we could create a separate function for all this, just like we did for set default, and then run this for the like we did with the set default. Instead of running create lambda, we'd create uobject, and then we would call the new function for this. So technically you can do this here. I'm just showing you this because these are the two most common ways, again, because you're not going to always be able to create uobject when doing a request async. You're going to have to do lambda on occasion. With that, that's why I did it this way, is just to kind of show you the two different ways. So all we need to do now is take this code we just written, and I'm going to copy it. I just collapse it so I can just easier copy, so I know exactly what I'm copying. So I'm just going to highlight it all, press Control C, and then right after this expression here, because we're checking if is pending, and then we're returning. So I don't have to type an else here, because if it is pending, then we're returning, we're exiting the function right here in this call. So I don't have to do an else. It's only going to reach this if this is in fact false. All right, so then I'm just going to Control V, and it's going to paste in all that code we just typed. And again, I'm going to collapse that just so we can see where we're at. So now we have this functionality in there twice. And then lastly, we need to do in here, so to close out the B is looking at. So if we are not looking at, so if true, we're running all this code if we are looking at it. But what if we're not? Well, we need to go else, interact widget, set visibility false. So if we're not looking at it any longer, then set it to false. And that's it. There's our set look at implementation. It's not too bad. It's a little bit convoluted because we have to put it in here twice, but it's just a simple copy and paste. So just make sure you copy and paste the correct section here. It's pretty much the entire function body of the lambda expression is all we need to put in there. And the reason why we don't have to put a return type here is because it's going to skip this else and it's come down here, and we are at the end of the function. So a return at the end of this function would be unnecessary. All right, I think we're going to wrap it up right there. I think this video ran long enough. I won't make you wait too long for the second part of this, but I hope you guys found this useful. If you did, please do me a favor, go down and hit that like button. If you're new to the channel, subscribe while you're down there liking it. Hit the notification bell so you know when that second part drops. And once again, thanks for watching. Until the next one, peace.